What's up, everybody? Welcome back to another live stream from Scalar Learning, and today we are tackling some more SAT problems straight from the source, straight from Khan Academy, and we are into circle theorems level 3. All right, here we go. So let's just make sure we are good to roll here. Everything's sounding good. Yeah. All right. So we're gonna knock out 5 problems in circle theorems. Here we go. These are going to be good to, hold on, maybe zoom out a little bit. Let's zoom out to here. Actually, let's keep it like this. All right, what we're going to do is take some screenshots and move them over here. This is the new OS. It's so cool. The screenshots pop up down there, and I can just do it so fast. It's great. Okay. A sector of a circle is shown at left with center point C and central angle X. So you see everything is in here so far. The radius of the circle is 15. That's there. The arc formed by the central angle X and point A and B has a length of 12. That's all there too. Beautiful. What is the measure of angle X in radians? Okay. This is talking about arc length. So all you want to do is as soon as you get in this situation, you should be like, we're talking about arc length. What's the formula for arc length? Let's just start there. Formula is length equals, hold on, let's get a thicker pen. Length equals the central angle divided by 360 times whatever the circumference is, which again is 2 pi r. All right. And again, it wants to know x, so that's fine. Now let's see if we can plug stuff in. Well, we know the length of the arc is 12. This is a no calculator section. Ooh, all right. We don't know the angle. That's what we're trying to find. That's cool. And we've got 2 pi, and then the radius is 15. Okay, now we got a nice little problem here, and we just got to solve for x. The only thing I don't like is this pi value, because we're going to have to estimate, which is kind of weird. That they normally, I feel like, don't make you do this on the SAT no calculator section, multiply out pi, but probably just estimate 3.14. So first I'm going to multiply 2 times 15. Then I get 12 equals 30 pi x over 360. 30 goes into 360 12 times, right? 12 equals pi x over 12, right? 30 is 112. Yeah. It's like 336, 112. Then I'll multiply both sides by 12. I get 144 equals pi x. And then I'm going to divide both sides by pi. Oh, they want it in radians. Oh, perfect. Because I shouldn't. Oh, this is way easier. Hold on. They want it in radians, not degrees. Now I realize. This is so much better. This is what I have to change. You'll see. I'm just going to keep it here, and I'm going to erase this. So when we're talking about in radians, this way we don't have to convert and do anything. Instead of x over 360, it's x over 2 pi. It's the equivalent of 360 degrees. So watch what's going to happen. This is so much nicer now. And again, it's over 2 pi. Well, actually, we don't even need to get to this step, because look what happens. 2 pi cancels out. And now I have 12 equals 15x. No wonder. Okay, this is more like a no calculator section. There's no weird pi calculation. Now we divide by 15, and this is actually 3 is 4/5 is what it reduces to, and as a decimal, that's 0.8. That's it. All right, makes way more sense now. Those little details, right? Okay, next, here, let's zoom out and get a full picture of this. Get rid of all this other stuff here. Goodbye. Oh, it's not going away. So weird. Okay, let's use that. Oh, there it goes. Yeah, let's just use the scissors, chop all this off. Sweet. All right, let's read the question and zoom back in. Oh, not there. Okay, in the figure at the left, the point O is the center, L, P, and N lie in the circle as they're shown. Line OP is perpendicular line segment LN, which is great, at point M. Circle O has radius of 10. So, hold on. That's not in the diagram, so I want to, here's what I'll do. Make it look clean. This radius has a length of 10. And then the length of PM, which is this little guy, let's highlight that in blue. Goes radius of 10. Okay, let's just say this length here is 2. Okay, which means this little length in here is 8, right? Anyways, what is the length of Ln? So they want this length. Now, look, here's what I'm going to do. Immediately in a circle, a lot of circle problems are really just triangle problems. And I know this because I see these problems all the time, so that just goes into my instinct right off the bat. You know, if you're new to these streams, I'm seeing these problems for the first time. I've never done them before, and I'm solving them live on camera with you. But I pick up these patterns now. As soon as I see a question like this, I'm thinking right triangle. So I'm just going to draw that in. And again, since this whole thing is 10 and that little guy is 2, this value actually here is 8. All right, and we want the length of Ln. Now, let's see what else we can opine. We can figure out. We want that length, and we know that's 2. I could probably create another triangle. Hold on, let me think. Oh, and then the radius is 10. That's the key. So the radius is 10, and guess what I just drew here? That's why we need this 10 value, because what I just drew here actually is 10, right? Because that's a radius or a radii. Now I know that this side is 8, this side is 10. What's this side? Well, this is a Pythagorean triple. If you know that, you know this side has to be 6. But if you didn't know it's a Pythagorean triple, a 3, 4, 5, or a 6, 8, 10, you can use Pythagorean's theorem, call that x. It'd be x squared plus 8 squared equals the hypotenuse, which is 10 squared. X squared plus 64 equals 100. X squared equals 36. X equals 6, right? We're subtracting 64. So we figure it out anyways. Well, that's 6, but they want this entire value of Ln. So if that side is 6, this side is also 6, equal. We could do the same thing here and draw that and figure it out. And so we know 6 plus 6 is 12. All right, next. In the figure at the left, hold on, let's take a screenshot first. Okay, figure the left point O is the center of the circle. Points L, M, and N and P lie on the circle diameter. NP is perpendicular to line segment LM, which is all good. All this stuff is on the diagram. The length of line segment QN, all right, that's the first thing that's not given, is 9. Actually, that's not, it looks bad. I have the luxury of having some colors to play with, so that's our 9. Oh, oops. What am I talking about? QN, that's not the whole thing. My bad. Actually, it's pretty chill. So look, QN, which is this guy, is 9. And the length of LM, this whole guy here, let's do it in blue. This whole thing is 30. And then it says, what is the length of N to P? N to P all the way up top. Okay, let's figure it out. I know that this whole thing is 30. I know this is perpendicular. Whenever we have a radius being perpendicular, like this, to a chord, these two segments are going to be congruent. So if this is 30, I know that this side here, let's actually erase that 30 because I want to do it separately. We'll say that this side is 15, and we know that this side is 15. All right, so any radius that is perpendicular to a chord, it bisects it, okay? Not that you need to memorize that per se, but you can kind of tell it looks like it's bisected, and it's okay to use a little bit of instinct here. So then we got 15 and 15, and again, we're trying to find NP. We're basically trying to find the diameter. All right, that's cool. And I know that this is 15. I know that this is 9. Let's see, what else can I figure out here? Where is that? So we know that that's 30. I'm seeing a nice right triangle here, but I don't believe we can say that this has been bisected. You know, we only know that that's 9. I don't think I know the radius because it doesn't tell me anything about the radius. If it did, we'd be done, obviously. It'd be double the radius. And let's think, what else can I opine? Let's see. What else do I know? Okay, I'm just thinking, if I did this, So this would be 9, 15. Oh, I see. I see what we can do. 9, 15. Well, again, in this case, since this is 15 up here, let's not do that blue. That's confusing. Let's say this is... It's a Pythagorean... It's not a Pythagorean triple. 9 squared is 81 plus 225. 81 plus 225. I'm using Pythagorean's theorem. This squared plus this squared equals x squared. Ooh, it's not very... This is not good because x squared equals 306. This is probably not the way to handle it. Because then we get this value, which is the square root of 306. I don't think that helps much. And it's a no calculator, so that's no good. Okay, let's read the question again and see if I missed anything. Okay. So we have line in the circle. NP is perpendicular to line segment LM. Yep. And the length of line segment QN down there is 9. Length of LM is 30. So no, those are 15. That's 15. I don't think we can say that this is bisected. You know, if this were bisected, this would be a piece of cake. You know? And then it would just literally be 9, 9, 9, 9 to be 36. No, there's something we're missing here. Hold on. 9. And if that's 15. And then the rate. All right. Ooh, I'm kind of stumped. Did I get QN right? Yeah, QN. The length of segment QN is 9. The length of LM is 30. Is there anything else that we can draw here? Here, let's see. What if I draw this chord and I get 15? Do I know anything about these angles? 15. Is this a 30, 60, 90? Hold on. Let's see, I think special right triangle. So I know that that's 15. I'm going to kind of have to guess here because I'm not sure, and I'm just going to use the best I can do. Whereas if I were to split this up, do you see what I'm saying? This looks like a 60-degree angle to me, like 30, 30, 30, making 90. Don't know how I can figure out if this is actually a 60-degree angle, but I'm feeling like it's a 60-degree angle. So I'm feeling like this is 60 and this is 30. The only thing I can think to do is then this side is 15 divided by square root of 3. Right? This is the middle side. And then this side is 30 square root of 3, but that doesn't matter. So this is 30 over square root of 3. Double this. Really just trying to work this out. 30 square root 3 over 3, which is 10 root 3. And this is 15 root 3 over 3, which is 5 root. That doesn't make sense. This can't be 5 root 3. You know why? Because 5 root 3 plus 9, which is the radius, has to equal this. You see what I'm saying? And it doesn't, according to the 60, 30, 60, 90, right? That's 10 radical 3. That is... So this should equal this whole thing. So it's wrong. So that was a guess. I really want to figure this out. I don't think I'm going to be able to pass this until I do. Why is I not getting this? Okay, so we have this information. So let's take away that 30 and 60. So we got 15 and we got 9. I know those values. The length of LM is 30. It's an isosceles. If I drew this down, it'd be an isosceles triangle, right? So it's isosceles. This is 15. This is 15. What else can I do here? And it would be a kite. So 9. I am really stumped. There's nothing else that I can do that I can think of. Huh. The line segment QN is 9. wonder if there's any comments. Let's see if anybody's got any ideas. Yeah, this one's really getting me. I'll look at the answers, and of course I'll explain it to you guys, whatever it is. But oh, this is gonna drive me crazy. Okay, hold on. Let's see if I can think. Give me 1 more minute of contemplation here. 15 and 9. So my usual thing is I draw the triangles, right? Usual thing is we draw the triangles. I know this is bisected. It's bisected. These two are equal, and that's my radius, let's say. And I know that LM going all the way across is that. And then what else can I draw in here? 9. Is there some theorem that I'm missing? 13, 15. NP. What did it say? NP it wants. LM is 30. That's the perpendicular bisector of LM. Like, I know we have to be able to figure out the radius. This is crazy. You see what I'm saying? 3, 4, 5. My only guess is this is a 3. No, it can't be a 3, 4, 5. Okay, let's just think of a 6, 36, 15, and that's 225 plus 36, 251. No, I'm trying, because there's a no calculator. I'm thinking like this has to be a nice Pythagorean triple, so we get all nice numbers, and then we get a radius value, and then we can sort of like boom. But nothing's coming to me, so otherwise it could be 9, 12, 15, but this isn't the, you know what I'm saying? That's not the hypotenuse. So we'll do x7. What's a Pythagorean triple with 15? 12, 15. Well, there's 12, 15, and 3, 4, 5, 20. I don't know. I'm going to go with 40. Let's assume that the radius is 40, but I really don't know. I don't know how they did it. I'm going to have to look at the answers. Let's see. 34. Okay, so let's take a look here. LQ and QM are both 15. I got that. Since the diameter is twice the circle's radius, determine the length of PN. If we give it, yeah, so the radius. So radius OL is, yeah, diameter's right. Line segment ON is also a radius of the circle. Okay. The segment addition postulate tells us that OQ plus QN, yeah, equals O, right? QN equals N, and OQ equals X minus N. Okay. So ON is the radius, and they're saying, yeah, whatever, that's obvious. Yeah, I know that that's X minus N. Oh, shoot. That's smart. That's, I get it. Look, so here's what we need to do. I should have just been more thorough. There's a relationship between this. If we call the radius X, and then we know that this is just simply X minus 9, we can so these are actually related now. Then I can do Pythagorean's theorem to find X. So then I can do, this is actually a pretty hard problem, I didn't realize. So then it's X minus 9 squared plus X squared equals, oh, sorry. X minus 9 squared plus 15 squared equals X squared, right? This squared plus this squared equals this squared. And then we can just simply do the algebra. So this becomes X squared minus 9x, which is 18x plus 81. 15 squared is 225 equals X squared. These guys cancel out. And then these guys combine. So it's negative 18x plus 306 equals 0. Negative 18x equals negative 306. And then we divide by negative 18. Let's see what this is. Must be 34. Or no, try 17, I guess. 1, 18, 12, 6. Yeah, 7 times 18 is 126. So then the radius is 17, and then the diameter is 34. Yikes. Oof. My opinion, all right, I'm not just saying this because I couldn't figure it out on my own, but I really do think this is harder than I've ever seen on a SAT for that extra step of sort of like putting this in terms of, man, if I would have just figured that, but that was the one thing. We have enough information to put this in terms of the radius, and then that would have been it. But yeah, I couldn't make that, just didn't miss that step. Oh, that's a good one. Okay, next, here we go. Oh shoot. Edit, view, zoom out. The figure at the left, point O is the center of the circle, and points X, Y, and Z lie in the circle segment. Okay, line segment OY is perpendicular. Everything is there, ZX. The length of line segment ZX, the whole thing is 24. And again, this is a perpendicular bisect. It's being bisected because of the radius is perpendicular to it. So the whole thing is 24. We know that this is 12, and we know that this is 12. And OY is 13. The whole thing is 13. What is the length of OW? So we know this whole thing is 13. All right, now we're definitely not getting this one wrong because it's a similar principle as the last one. So figure that out. So we know that OY is 13, and we want to find OW. So we can make some pretty nice things here. Do a little Pythagorean theorem again. Let's make that blue. Okay. So first of all, if I call this again, the radius is x. Well, this is also the radius. Oh wait, it's 13. I don't even need to call it x. Since this OY is 13, this is 13. And then now we can do Pythagorean theorem, and it's actually a Pythagorean triple, but let's just call this x. Not x since there's an x in here. Let's call it, I don't know, a. All right, so that's this length here is a. So now we've got a squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. Subtract 144. A squared equals 25. A equals 5. But that's a 5, 12, 13 triple, and that's OW. Okay, next. There we go. In the figure at left, point O is the center of the circle, and points L, P, and N lie in the circle, or on the circle, excuse me. Circle O is a radius of 17 and length of P. Okay, hold on. So circle O has a radius of 17. Let's go ahead and draw the radius out. I'm sure we're going to have to do this. Radius of 17. And the length of PM is 9. So this length is obviously 8. What's the length of LN? So we want this going across. All right, you already see we have this set up perfectly. Now we have a right triangle 8, 17, and we need to find this distance. Because we need to find this whole distance, well, again, it's bisected. These two segments are equal because this is a radius that's perpendicular to it. So how do we do this again? Pythagorean theorem. 8 squared plus x squared equals 17 squared. It is a triple. I think it's 8, 15, 17. But no calculator. Let's just do it out. 64 plus x squared equals 170 plus 119 is 289. Subtract 64. X squared equals 225. And of course, that's a perfect square, which is 15. So we know that this is 15, so the entire length of ln is just, that's 15. That must also be 15, therefore it's 30. All right, that is it, my friends, for the live stream. Yes, 9, 12, 15 is a Pythagorean triple. Any tips on, okay, so we got to find the height of the triangle, then add the radius. Okay, any tips on reading? I usually get 800 in math, that's awesome. And did terribly on reading, 19 wrong. Okay. Here's the thing. I can't give a lot of super specific advice in terms of reading because I just simply read and I just do a ton of practice if I were to take it right now. Did the same thing with the SAT when I was taking it, same thing with the LSAT. I just practice. So I think you'll unwind and unravel your own reading tips. I have a reading specialist that I might have come onto my channel the week before this SAT and talk a little bit about reading. But Erica Meltzer's reading book helped a lot. Okay, good tip. Yeah, I'm going to be doing SAT cram week for sure for August 24th. Absolutely. PDF of it right now. I plan on using it throughout the summer. All right, guys, that's it. If you like this video, please click that like button. It really helps the channel substantially. I would really appreciate it. Thanks so much for joining. And if you have any questions that were not answered or things that you're confused on, leave a comment in the comment section. And I'll get back to you ASAP, as always. Thank you guys so much for joining, and I'll see you all next time.